Good afternoon, everyone. Welcome to today's presentation, sponsored by Seal Aftermarket Products. We'd like to especially thank Seal Aftermarket for making these webinars free to everyone, including non-members of ATRA. Here is a short video from Seal Aftermarket.
Seal Aftermarket Products engineers and manufactures Toledo Transkit, the most trusted and complete kits in the industry for 25 years. Toledo Transkit gives you more critical components, more OE components, like premium seals and gaskets, more design enhancements, patented components, and all the little extras you won't find elsewhere. At Seal Aftermarket Products, we don't just make kits, we make kits better. Toledo Transkit is the #1 choice of installers because of all the intensive research and development that goes into each component in every kit. Like re-engineered valve body gaskets, preventing EPC damage by eliminating the shredding you get from original equipment. Plus, all of the extra essentials that are included, like spring and screen filters that should be changed at overhaul. Toledo Transkit even includes loose valve body gaskets that fit all 19 bonded separator plates. When servicing Honda and Acura transmissions, shaft nuts are quite often damaged during removal. Toledo Transkit provides all the main shaft, secondary shaft, and counter shaft nuts, so you don't have to try to reuse the originals or pay extra for them at the dealer. Honda Acura kits also include valve body screen filters, pressure tap washers, and other important components like bolt locks, roll pins, and pistons. What you get is a complete kit with great fit and no wasted time or worry about ordering extra parts. If you want the best sealing transmission kit in the industry, ask for Toledo Transkit by name.
Okay, if you have any questions or comments during the webinar, feel free to just text me. If not, you can send your emails to webinars@atra.com. And any questions sent over a text, I will try to answer those the best that I can. Here's the schedule of the rest of the webinars for the year. The next one will be June 23rd and the 24th on the 6R140, and we're going to go over the introduction of that transmission. Pencil it in now. This is the expo dates for Las Vegas. We'll be at the Rio again this year, and it's from October 29th to November 1st. We hope to see you guys out there. And we just did the seminar in Tulsa, Oklahoma. The next one will be August 8th in Albuquerque, and you can see the rest of the schedule there. Now, along with the normal giveaways or door prizes that you get from the vendors, ATRA has also been giving away some great prizes. We give away a free package to go to the expo, where you could go to all the tech seminars or management ones, whichever ones you want to do. Along with that, we're giving away the 4-night stay. So with the complete package, you get a 4-night stay at the Rio. All you have to do is get yourself there and pay your expenses while you're at the expo. We're also giving away one management package for the expo also, but that one does not include the hotel. And we also give away 1 month free tech service for ATRA. If you're already a member of ATRA, you would just take a month off your bill. And then last but not least, we also give away at each seminar that we do around the country, last year's expo book, which is almost 800 pages of tech that we did at the expo last year. Today's presentation, we're going to talk a little bit about the ZF8HP. We're going to talk about the internal components. I would like to cover a complete rebuild, but obviously it would take more than the amount of time that we have for a webinar. So basically, we're going to go over some rebuild tips and some of the internal components on this transmission. As always, we mentioned the transmission identification. It's always good to use the serial number or any information you get from the ID tags found on most transmissions, especially when it comes to ordering parts. It can be crucial because of all the different vehicle models that you'll find these transmissions in, and the list is endless as to what ZF is gearing up their transmissions for all the different kinds of models out there. We have two brake clutches up front. The A and B clutch are brake clutches. They spline into the case or into the front housing. And then we have three driving clutches, E, C, and D. And we have 4 planets. You notice that we have 3 planets up towards the front and 1 all the way in the back. Here's the clutch application chart. And you can see in first gear we have both A and B clutches holding, the C clutch is driving. And we're taking off at a 4.69 to 1 ratio. As we go down the list here, you can see in 6th gear, we have all the driving clutches on, and we're actually at a 1 to 1 ratio in 6th gear. This is sort of the clutch layout if you remove the transmission assembly out of the case. You have to carefully remove this out as one piece. This will come out as one assembly. You have to be careful here. This P4 drum shell, we do not want to cause any damage to that. It's kind of brittle. It can easily be damaged, so we have to take care when we remove this whole assembly out. Now, as you can see, the A clutch will spline into the pump housing, or actually that should be the bell housing. That housing is stationary, so that's your brake clutch. And you can see right here where it splines onto the hub right here at the top of the assembly we're showing you here. Now the B clutch, that splines right to the main case. You can see that here. So that's our other brake clutch, and you can see it splines onto this hub. And then we have the C and E clutch drum, and you can see that splines onto this drum here. And this is the C clutch. And then the last one is the D clutch. That'll spline to the D clutch drum, which we're looking at right here on the right. And all this will be assembled inside this one piece. And we'll go through that as we go through the webinar. So if we want to start disassembling this assembly, the first thing we have to do is remove this snap ring that holds this ring gear in place. Now this snap ring is a one-time used selective snap ring. And you have to be really careful taking the snap ring out because you can easily chip the actual shell right in this area when you're going in there with a screwdriver. One of the other things you have to remember is that there's a notch cut out in the snap ring that has to align with this rivet. Now obviously once we get the ring gear off, we can pull all of our assemblies out of the shell itself. Now there's a factory tool that they give you that you can actually put around the shell so that when you go in there with a screwdriver you won't damage. It'll give you something a lot stronger support for the screwdriver or the tool you're using to pull the snap ring out. Now according to the factory manuals, they want you to actually start 180 degrees opposite of this snap ring opening. So we're going to go all the way to the other side of the drum from the snap ring opening and start there. And then we can go ahead and remove the complete snap ring and start taking the parts out of the shell. Now some techs don't have the tool. They're actually using a very large hose clamp. They'll take the hose clamp and just go right around the shell with it to give it some support so they don't cause any damage to the shell itself. Miller Tools also have these little tool packages you can purchase. There's 3 different kit numbers, and they talk about the different year models that they're making these little tools for. Now I know it says $115 for these here, but I've seen them on the internet and in some places lower, and sometimes the prices were even higher. So it pays to shop on the internet and see what you can come up with as far as the price for these. But you can see they're pretty compact. There's several of them for different type of size shells. Now the P1 and P2 planet assemblies, you can see that we have the main shaft here, and in the middle of the main shaft is the P2 planet. So on top of that, we're going to place the P1, P2 sun gear, then we have the P1 planet, and then the P1 ring gear. Now from the other side, we're going to actually assemble the P2 ring gear, and also have the P3 sun gear on it. Now the next thing we're going to do is we'll have the components inside the P4 sun gear shell, or what's also referred to as the C and E clutch drum. Let's take a look at the C and E clutch drum. In there we have the P3 planet, the ring gear, and then you can see our E and C clutches are actually splined in here. And then of course we have the P4 sun gear shell, which has the P4 sun gear located there. Now all this will get assembled down into the D clutch hub. That's going to spline into the D clutch, which sits down inside of the P4 planet. Again, this will all be brought down into the shell, the P4 shell. And as you can see, if we flip the shell around and look down inside, the P4 analyst or ring gear is located at the bottom of that shell. It's actually got a snap ring retainer that holds that in place. Kind of what the E-clutch assembly looks like if you take all the pistons and the return spring and all that out of it. And this is the C-clutch assembly. You can see we have some molded pistons in here. These should be changed during rebuild. We're also going to have some balance pistons that will have rubber seals on them, but they're not as crucial, but they also should be changed as well as any molded piston. And this is the D-clutch assembly as we were looking at earlier inside the planet. Now it's a little different with this clutch assembly. You'll find a molded piston inside that's riveted in place. I want to talk a little bit about the balance pistons. There's many different units today that use balance pistons. Basically how they work, as you can see here, number 6 is the actual piston itself. It'll have lip seals on it, or it could be a molded piston, but the lip seal is molded to it. And then you have the return cup spring, or any type of return spring would be located here. And then you'd actually have your baffle plate, or what's called the balance piston itself. The lube oil will travel up through the shaft and come out through a lube orifice, and it'll fill this area with oil. Now we have a seal at this end for 2 reasons. Obviously, centrifugal force is going to have the oil held in here, and this is going to help seal it, but also prevents any metal debris from developing from the piston moving up and down along the other piston. This oil is going to prevent the clutches from applying during centrifugal force because it's a balanced feed, helps keep the clutch off. Now during shifts, it's more reliable for engagements and shift control at any type of speed. So this is a way for them to control hydraulically the clutch can apply to keep the shift refinement right down to where they want it. So now they can actually control the apply pressure and release at the same time. Now this is kind of a standard method that I've noticed from a lot of the factories. They basically want you to take the clutch assembly and they want you to compress it. As you can see, there's a wave plate in here, so they want this compressed so you can take a measurement, and then they want you to measure the height, and then that's how you figure out what your total clearance is going to be. I have an alternate method that I like to use, and it's kind of across the board. Again, you can do it the same way by compressing it, but I use an H gauge. What I find easier here is to take the wave out, take a measurement of the thickness of the wave, and then you can make your measurements and you just go ahead and subtract that amount of the thickness of the wave plate from your actual adjustment. Now we can just take our H gauge and flip it over, make our measurement, again subtract the thickness of the wave plate, and then you have your clutch end play. The same method kind of throughout the rest of the transmission can be done the same way, whether you're compressing the clutch pack or just removing the wave plate. Take your measurement between your snap ring and your pressure plate, obviously subtract the amount of the wave plate, and you can get your end plates that way. And this is the list of the rest of the clutch clearances that we have throughout the unit. Now this is something that may vary from model, so you should always check the model you're working with and make sure that the end plate is set up according to whatever the factory specs are for that model. There's quite a lot of them, so it's always best to check that. There's not a general rule to all ZFs. And ZFs, not only the clutch clearance is really crucial for shift timing, shift overlap. A lot of the complaints we get on the tech line with shift feel, a lot of the times just due to the clearances not being correct. Now here's some valve body information for you. As you can see in the upper right corner, we're showing a couple of sleeves that go in the valve body. The steel one will come out when you remove the valve body from the case, and that one can just pop right there out of the valve body. The other one, you have to split the valve body to get that one apart. So what we're showing you here is the area where you're supposed to pry the valve body apart. The idea here is to keep the separator plate with the upper body because it contains all the small parts. So we don't want to lose some of those parts and get confused as to where they go. This is a common plate that you'll find in a lot of ZF6s and ZF8s. It's called a silk screen design. This is supposed to be replaced any time the valve body has been separated. A lot of times, this one here, as you can see, is pretty new. A lot of times you'll find damage along the silk screen that could cause cross leaks. Now, what some shops are doing is they'll take the original plate and they'll put it in the water, of the hot water that you're using in the parts washer to kind of loosen it up. And then they place the plate on a flat piece of granite or glass. And then they'll take a flat stone and basically smooth off all the silk screen. I know of a shop that's doing this quite often. They've been doing it for years. It's been working fine. But again, you cannot use a whiz wheel here or some kind of a Scotch-Brite buffing pads. You want to use a flat stone, and you have to have it on a flat surface. You can clean all this material off. Make sure that your case surface, both sides of the valve body are all flat sanded the same way. And then if everything's torqued to specs, you should not have a problem reusing the old plate. Here's some of the small parts that you'll find in the upper valve body. Of course, we have all these accumulators. There's 7 in this valve body. These may also vary from model to model. The main objective here is to make sure that the accumulator sticks up just above the surface. We don't want it down below the surface. Obviously, at that point, you'll check and probably find that the rubber ball on this side has been flattened out. There's a lot of aftermarket sources for repairs for this. What I find kind of cool about the ZFs is they always use these rocker balls. They'll have a little rocker ball in this bathtub area. This basically almost works the same way as a bathtub with a single ball in it, except they're just using 2 balls for the pressure to teeter. The pressure comes down, teetering the other ball down, which actually raises the other ball up. So it primarily works the same way. Okay, there's some more parts in the upper valve body. You can see there's our sleeve. There's a little notch here that prevents it from coming out until we split the 2 valve body halves. We have several check valves here. And we also have all the spring dimensions for you in the handout material. Now this check valve that you see here, the only time that I found this in the valve body is with vehicles that have the start feature. That's with the hydraulic impulse storage system. So basically the vehicle comes to a stop, the engine shuts off, but during driving the transmission will fill this accumulator, this storage area. And then when the vehicle shuts off and it gets ready to take off again, a valve will open up and all this oil can go back to the clutch so that when the engine restarts, we're ready for takeoff and we have the clutch pack filled. And I'm just giving you some close-ups of how these are set up. As you can see here, we have this little notch that has to, you have to keep this window open to this cutout right here. So that has to be kept aligned. And a couple more close shots of some of the small parts that will be found in the valve body. With the handout material having the spring dimensions, you won't have to worry too much about mixing up some of these springs. You can see exactly where they need to be placed back. And also we have the check ball locations for you. Again, this may vary over different models, so be careful when we remove the valve body plate. Make sure that we don't misplace one of the check balls. In this particular valve body we have here, it shows 6 check balls. Now these normally are that white nylon type of material, white plastic. They're known to deteriorate. They're known to become damaged. We've seen them go right through the actual valve body separator plate. So it's something we have to be careful of, something we have to look at. Now, this is the upper valve body. This is one side of it. We have the valve body exploded view here for you. This is what I call blueprint in valve body. Have all the valves are out. Now, the B clutch or NIC, which is like a neutral idle control valve, this is controlled by the computer during idle and a stop drive, stopping in the drive gear. What they do is they release the clutch partially. And this reduces any drag on the engine. This is to help save fuel, so it's for economy. But they'll actually have the clutch slipping at a stop, so that it's not pulling down on the engine, consuming any fuel, extra fuel that way. There's less load on the engine. And this is the other side of the valve body. You can see the torque converter valve here. And then we have our default position valve. A lot of times guys will take this valve out of the bore and not realize that there's one more small valve inside the bore. We don't want to misplace that. Make sure you check for that when you remove the valves from the valve body. Now this is the lower valve body. You can see we have several bore plugs. We have to check these bore plugs for looseness. These have a tendency to wear out, the actual bores. There's aftermarket fixes for this stuff. We need to really check these valve bodies thoroughly. Most of the times we concern ourselves a lot with the condition of the valve body, where we're also seeing quite a few problems with solenoids themselves. So we've actually had guys swap the solenoid with the same connector color just to see if the shift changes. If it does, then we know we have an issue with the solenoid itself. If not, then we have to really get inside the valve body and see what may be worn out. Obviously, this is an E-shift setup. It has a park release valve. One of the things I do want to mention is if you look closely, you'll see the retainer that holds the bore plug, the opening actually goes down inside the valve body. And you just take a pair of needle nose pliers so you can align it up so that when we do put it back in the valve body, we have it in the right location so that when we put the retainer in, we're not too far in or too far out with the bore plug. And this is the other side of the lower valve body section. You can see this is a park release piston. Hydraulic pressure is going to help pull this out of park, and then once it does, it will go into this lock solenoid which will hold it. So this solenoid is mechanical. This is not a hydraulic solenoid. There's actually no oil pressure going to that solenoid. Just basically to hold the park release piston in place. Now the torque converter and pump drive assembly, as you can see here, this is a chain-driven double-stroke vane type pump. And you can see inside the converter hub, on the inside near the bottom of the hub, you'll find a spline that actually goes right to this driven sprocket. So that means that this pump will be turning when the converter turns. We have our typical captive clutch in the back, our dampener, and then as you can see over here we have a chain that's going to drive the dual chamber pump. A little bit closer look at the actual converter. We took the drive sprocket off, and you can see where it goes right down inside the converter and splines into this lower spline here. Now the stator support and pump assembly, we're going to show you that real quick here. Obviously we have the A clutch and B clutch pistons are in here, in this location. We have to disassemble this to get the pump out of it. So we're going to go ahead and remove the pistons. And then we have a snap ring. We take that snap ring out that holds the A clutch in. And if you just lift up on the hub itself, it will remove all the clutches and steels except for the last one. So you can lift these all out in one piece and go ahead and pull out the last plate. Then once we do that, we can compress our spring, take the half moons out, pull the last piston out, and now we can actually see the bolts that hold the two halves together. Now, you're going to have 5 of them inside underneath the piston, but you also have one more here on the outer side, and you can see it right here really clear. That has to be removed also. Now, once we do that, we can split the halves, and now we can start getting to our pump. Once we remove this, we can go ahead and lift the hub and the pump out at the same time. This will take a little bit of prying. As you can see, we have a couple of O-rings here. So we just have to pry that up and lift everything up in one assembly. Now that we have the pump out and we can get to it, there's a small little circlip here, or snap ring. We can take that off. That actually holds this bevel in place. And as you can see, this plate will come right up after we do that. And underneath you'll see there's another little clip here. We have 2 of these on here. And notice by placing a quarter next to the pump itself, you can see just how small this pump is. Even though it's small, it's quite efficient for supplying the oil pressure needed, and in a quick hurry they can get that pressure right up and right to where it has to go. So this is a pretty efficient pump. What's unique about this pump is that it has 2 inlets and also 2 outlets of the pump itself. This also helps preventing any type of pump noise or any type of cavitation. System pressure is about 80 psi to 250, about 450 max. This will displace about 1.85 US gallons to 5.1 US gallons in a minute. So that's pretty good. A pretty efficient pump. Here's a little quick oil schematic of how the pump works. As you can see, we have our pan or our sump here. We have 2 inlets, one on this side, one here. Then our output pressure will come out of 2 different ports. And then, of course, our pressure control solenoid will work on the spring side of the valve to control line rise. Here's an exploded view of the pump, so you can actually put it back together. You have an exploded view right here. As you can see, we have our first clip that we took off. We took off the snap ring that held this. Then we can replace this or lift up this cover. And then that other clip that I told you actually goes right here in this location. Then we have our rotor, the vanes, 2 alignment pins, the internal pump itself, and then the bottom cover, which we have a seal right here. This is the bottom. Look at the other side of the cover itself, and that seal obviously has to seal on the shaft. And there's the actual driven sprocket that turns the pump. If you wanted to do some air checks where the transmission is partially assembled before it's actually put into the case, we identified some of the oil circuits here in this input shaft. So you have TCC apply, E clutch, and C clutch apply. I always believe in using a regulator on the blow gun and to regulate it down to about 30 psi when we're doing our air checks. Also, when you hand out material, you have the case air checks. So if you're looking at the worm tracks of the case itself, this is the front of the transmission up this way. And again, we want to check this with 30 psi of regulated air also. And once the clutch pack is assembled for the D clutch, we can air check that one also to the output shaft. Good question. How many quarters does it take to buy that pump? I really don't know what the cost is. You'll have to check with your supplier on that one. Okay, there's a couple of differences in the pan. The 845 RE is found on the Jeep Wagoneer. It's a little bit a deeper pan. You can actually, if you wanted to use this pan, it would increase the fluid capacity, improve lubrication. As you can see, the sump and the filter is all in one. It's just one big piece of plastic. We recommend using the OE fluid. Recently, I've just been visiting some shops, as I usually do once a week. I go out to all the local shops in this area, and we've had several 2011 6R80. Just the other day, was having a problem with TCC shutter. Basically, all they did was take the fluid out, put the latest LV fluid that it required, and it actually took care of the problem. But this was an issue where the transmission was removed a few times. The converter rebuilder was going through the converter trying to figure out why this thing had a shutter. If you're using something as a universal fluid that you have that's synthetic and it's working for you, that's fine. But when you do run into a particular problem, and you may want to just go ahead and try what's recommended for that transmission to maybe correct the problem. Service and fill, pretty simple here. The front of the transmission is to the right. We have a drain plug at the back. And right there in the right rear corner of the trans, just above the pan rail, will be your fill plug. Again, this is important. We mention this on every type of transmission that's filled this way. You have to have the transmission at whatever the factory specs are as far as temperature goes to correctly have it filled. If you let it get too hot, obviously it would be draining too much fluid out, and we'd have an issue with that. And obviously, if we don't let it get to temperature, we could still have it not filled correctly. So we need to follow the factory specs on how to do that. Question was, is Chrysler using ZF fluid as well? More than likely, I believe the Chrysler fluid will have a different name to it. Again, I would use the Chrysler fluid on a Chrysler, and if I was working on a Jaguar or BMW, I would probably go with their fluid. Don't forget, even though it's the same type of transmission, the software strategy may be a little bit different for a Chrysler versus an import, or I should say a European. So it's always recommended to go with the recommended fluid for the model that you're working on. I know we always talk about what are we supposed to do, supply different drums of oil for all these different vehicles. Basically, it's not that difficult. I remember when I had my shop in Miami, every time a Honda came in, we would just order a case of fluid. It was not that expensive. Just like the Ford recently, when I was at the shop yesterday, we were just talking about that. And we were talking about, well, when that particular Ford comes in, if it's that year, make, and model, a case of fluid really was not that expensive at all. The price was pretty good compared to using. They also in drums they store a universal synthetic, and they use it on everything. On this particular vehicle, it gave them a problem, so they ended up going in with the LD fluid, which was not much more than the cost of the fluid they were using. They use it on Hondas. I suggested if they used the Honda fluid, it was actually cheaper than the universal synthetic fluid that they were using. So it's something you have to look at, the different models, price it out. Um, if the cost is not that much more, I mean, that gets passed on to the customer, but it's always a wise choice to always go with the model fluid that goes to that vehicle. So if it's a Honda, it's Honda fluid. If it's a ZF and a Chrysler, I would use the Chrysler fluid. If it was a ZF and an import, I would go more than likely. I would rather go with the brand that goes to that vehicle. Okay, we have some torque specs here for you, and that should be all the torque specs that you can see there. You can also see that we have a couple of them that are torqued to a certain spec, and then you have to go another 45 degrees on the bolt. TCM adaptation. Everybody always asks, do I still have to adapt the transmission even though I just had it reflashed? Yes, you do. Even if you just changed the computer and it came with the latest and greatest software, it still has to learn the transmission. So if the transmission's been replaced or it's been repaired, even if just the torque converter's been replaced, any work done to the valve body and repairs on the transmission, you should always go through and do an adaptation. Now with the scan tool, make sure there's no codes anywhere. Sometimes if you're using an aftermarket scan tool and you put in the year, make, and model of the vehicle you're working with, you may miss some codes. But if you go into the global or generic mode, you'll find any codes that could affect fuel economy, and those codes will come up, and that could affect your relearn. So it's always good to check in the generic or global mode to make sure there's no codes anywhere. Basically drive the vehicle till the temperature gets above 86 degrees Fahrenheit. Now, once you've reached that normal operating temperature, just go ahead and monitor each actual gear with the scan tool. Make sure everything's shifting okay. We want to drive this with light to moderate acceleration, 10 to 20% throttle. And make sure that we go through all the gears, at least up to 47 miles an hour or faster. After we've done that, we basically want to come to a coasting stop. We don't want to do any kick down shifts or anything like that. We want to get the transmission to learn a normal coast down and like a normal to light throttle upshift. And if you do that 4 or 5 times, you should be okay. Different models may require a little bit more adaptation. I've had some vehicles where I've done this and the adapt seemed to be taken, but I noticed I'm getting a coast down clunk. So if the clunk is from 3 to 2, I'll take the vehicle out, shift it into third a few times, let it upshift to third. I'll kick it down to second a few times. Doing that sometimes will clear up that particular shift complaint. So there's different things you can try, but this is the basic adaptation that you should do after rebuilding the transmission. Just something a little odd about this particular ZF I wanted to mention. As you can see, this is an all-wheel drive setup, and the vent on this was kind of unique. As you can see, there's an access plug that lets you get right to the vent, but I didn't want anyone to get confused that they had a front seal leak, because this was the actual vent coming off the transmission, and we didn't want to make a mistake and think that it was leaking out the front when it's just oil venting. So I just thought this one was a little bit different, so I wanted to mention that. And today's presentation was also brought to you guys in part by Ray Bestis, so I want to thank them for that. And here's a short little video from Ray Bestis.
And at Ray Bestis, performance, quality, and reliability are a part of every product.
Telmoy from Telmoy Transmission in Tampa, Florida. I've been rebuilding transmissions since 1975. We have been using the Raybest's GPXs and GPZ clutch plates. We use the GPXs in all of our Honda rebuilds. We build a lot of diesel high-performance transmissions, and we use the GPZ clutch plates in this application. We also use them on our everyday heavy-duty, hard-working work trucks with great success. I believe these GPZs are the best clutch plates I've ever used. They give us the durability and the performance that we're looking for.
And at Raybestos, performance, quality, and reliability are a part of every product.
And we'd also like to thank Whatever It Takes for co-sponsoring these webinars also. And again, today's presentation is sponsored by Seal Aftermarket. If you have any questions at this time, please go ahead and text them to me. If it takes you time to text them in, just go ahead and click on the little hand icon next to your name so that I know that you're texting in. I want to thank everyone for attending, and I hope to see you at the next webinar. Also would like to mention, after this webinar has been viewed, you can also go to the ATRA website and download the video for it. If you're not a member of ATRA, you can go to Seal Aftermarket Products website and you can download the video from that. So if you have any questions, please by all means go ahead and text them to me. Again, thank you all for attending.